In this Montessori moment, we are going to explore the checkerboard, a Montessori material used for multiplication. The checkerboard is based off of a method of multiplication similar to lattice multiplication, a technique used by mathematicians as early as the 13th century. Lattice multiplication consists of drawing a lattice or grid between the multiplicand and multiplier in order to break calculations up into smaller steps. The checkerboard is actually much closer related to a technique described by Pythagoras in the early 13th century, which he called quadrilatero in forma scacchiere, or rectangle in the form of a chessboard. To use the checkerboard for multiplication, we will also need a box of bead bars from 1 to 9, and a box of printed numbers. Having a notebook handy to record results in is great as well. In case you are not familiar with the Montessori bead bars, they are color-coded beads wired together in increments from 1 to 10, but when using the checkerboard, we never use a 10-bead bar. Each square on the checkerboard gives these bead bars power, and that power comes in the form of categories or place values. The bottom row of squares from right to left represents units, tens, and hundreds, which make up what we call the simple family. Units of thousands, or thousands, 10,000s, and 100,000s, which make up the thousands family, and millions, 10 millions, and 100 millions, which make up our millions family. The right column has 4 squares, and from the bottom to the top, they are units, tens, hundreds, and thousands. The grid of checkers created by the bottom and right side are all permutations of these same values, multiplied against each other. This creates a patterned effect with the traditional Montessori math colors of green for units, blue for tens, and red for hundreds. It also creates diagonals of same values that we will get into in just a bit. Numeration works like this. We can take a bead bar, for example for the number 1, and place it on one of these squares to give it value. This one is on the units square, so it is worth 1. If we move it to the left into the tens square, it is now worth 10. Moving it to the hundreds square will give it the value of 100, and if we continue to move it to the left, its value increases 10 times as it moves across each square. The same thing applies to this bead bar of 4. It is worth 4 in the units square, 40 in the hundreds square, 400 in the hundreds square, and so on. Using several bead bars at the same time can give us a multiple-digit number, like this, 2,463, or this, 745,036,904. Let's do some multiplication. Most students using this material for the first time will focus on numeration or single-digit multiplication, but you seem like you can handle a bit of a challenge. We are going to go straight to using double-digit multipliers. To set up a multiplication problem, we can write a problem down, 75,826 multiplied by 39. Then we can use the printed numbers to prepare it on the checkerboard. The multiplicand is placed across the bottom, and the multiplier is placed along the right side. Each number in the multiplicand relates to a bead bar, and each number in the multiplier tells you how many times to take it. Starting with the smallest category, units, we start placing the bead bars. Once we are done, the 2 rules of the checkerboard come into play. The first rule is that we cannot have more than 1 bead bar in any square. The second rule is that no bead bar may exceed 9. We will go through and exchange multiple bead bars for either an equivalent bead bar or for 2 bead bars in the case of a double-digit answer. For example, our unit square here has bead bars of 6, taken 9 times. Counting that out, we have 54. There is no bead bar of 54, so we take both a bead bar of 5 and a bead bar of 4. We place the bead bar of 4 in the unit square to represent 4, and we place the bead bar of 5 in the tens square to represent 50, as it is really 5 groups of 10 that have been exchanged to the next place value. This occurs again in the tens square, where we have 2 taken 9 times, which is 18. We will have to use bead bars of 1 and 8. However, there's a bead bar of 5 also in here that resulted from our first exchange. We have to add that in as well, which gives us 23. So we need bead bars of 2 and 3. The rest of the exchanges will look like this in our units row. We then move to the tens row of our multiplier, where we will do the same thing. 2 last steps will give us our final answer at this stage. Remember how the values on the board created those beautiful diagonals. Any bead bar placed in any of the squares that are aligned in a diagonal will be worth the same value, so we can just slide everything down each diagonal to the bottom row, where we will go through and exchange each group of beads one more time. Now we have our answer, and we read it like this: 2,957,214. Once the child has reached mastery of their multiples and confidence with the mechanics of the checkerboard, we introduce a greater challenge. Let's go back before we slid all of our bead bars down those diagonals. What we have here are actually our partial products that, once slid down, are being added together to give us the final product. We show the child that they can write their problems top to bottom and record these partial products, which once added together will give the answer. This eventually leads to more and more reliance on paper-based multiplication, with a very concrete understanding of what is happening in the abstract. Thank you so much for being part of this Montessori moment. What shall we explore next?